Which of the following skeletal structures represents the condensed structure that is given here? So in a skeletal structure, you'll notice we don't see the carbons or the hydrogens directly. Those are all implied. In our condensed structures, we do include the carbons and the hydrogens, and what we're not showing is all of the covalent bonds. So what we want to do, I think, as a first step would be to expand out this condensed structure so we can see how long of a carbon chain we have and also if we have any branch points. So the first thing that I notice is that we've got two of these CH3, CH2 groups. So two carbon atom groups are called ethyl groups. So we've got two of these ethyl groups attached to the same CH. So I am going to start by drawing one of them. So CH3, CH2, so I've drawn one of these groups, and I know it's attached to a carbon with just one hydrogen. And then this is telling me that I have another one of these same groups attached to that same carbon. And then it looks like the chain kind of carries on. So I'm going to make one of those kind of a branch. So I can either put it up or I can put it down. It doesn't matter. So I'm going to draw it down here. And it's the CH2 that is attached to that CH. And then we have a CH3 at the end of the chain. And so we know which order to write this by paying attention to the number of bonds on carbon. We want to make sure that carbon, so let me show that single bond between them. Carbon only ever has 4 bonds. So that's why we know the CH2 has to be the branch point, because we've got 2 bonds to carbon, we can only have 2 hydrogens. And then moving along the chain, what this portion tells us is that we have a chain of 4 CH2 groups. So we can put in that chain of 4 CH2 groups. And then at the end of that chain, we have a CH3. So when we want to take this and convert it from this condensed structure, so this is still a condensed structure because we're not showing all the covalent bonds. It's just a more expanded version. What I like to do is I like to number that longest chain so I can figure out how long of a chain I'm looking for and where my branch point is. So I'm just going to number from left to right. So I can see I have an 8 carbon atom chain, and then off of that 8 carbon atom chain, I've got another 2 carbon atoms. So if I wanted to convert this to a skeletal structure, I would draw this 8 carbon atom backbone. So by doing this, I've got 1, 2, 3, 4, 5, 6, 7, 8. Then I would say, okay, on 1, 2, 3, 1, 2, 3, on that 3rd carbon, I need to have 2 carbon atoms. And then I want to pick this structure out of our options. So the only 2 that really look like possibilities at first glance are A and C, because we've got that bonding pattern of these CH3, CH2, these ethyl groups attached to a CH in both of these. And so then we want to see how long of a chain it is. So we need 8 carbon atoms. So in A we have 1, 2, 3, let me number them, 1, 2, 3, 4, 5, 6, 7. So that's not long enough. So it looks like C is going to be the right answer here. So 1, 2, 3, 4, 5, 6, 7, 8. And these 2 structures match. The fact that I drew this bond going this way, and on this case going this way, those are single bonds, they can rotate, so this is still the same molecule.